Okay, so I'm going to show you these classes, and then we're also going to write a tester program to accomplish a couple things. We're going to print out all of our vehicles, print the maintenance plan of all the vehicles, figure out the average wait time of the buses, and then we're going to ask some kind of questions or queries about our little mini data set we're going to create. We're going to say, hey, show me all the vehicles that might be intersecting with traffic, meaning not have a dedicated lane. So you can think about if you're managing a system and you want to say, hey, I have something going on with my traffic right now. Show me all the vehicles that might affect. Or show me all the vehicles that accept a card. So, someone's searching the public transportation website and they say, I only have a credit card. What are my choices? Show me all the vehicles whose fare are less than $5. Show me all the electric vehicles. I'm doing a study of green transit. I want to know all the ones that run on electricity. Then show me all the vehicles that go on Route 43. I need to take that route. Show me the different ways to get there. So I'm going to start with just the parent class. So this is my abstract class, abstract transit class, and I implement payable, and I've also implemented comparable. A lot of times it's just a good idea to implement comparable even if you don't see a use for it right now. You very well might in the future, and so it's a good idea to just kind of have it there. It's kind of like the equals method. You most likely will end up using it at some point, so it's a good idea to have it there. I have my instance data variables that I talked about. Let's quickly flip over to look at power source. So here's my enum. I have my three values, gas, electricity, and compressed natural gas. I have two variables associated with each one of them. One is a Boolean, talking about whether or not that type of power needs to be refilled. And then one is just a string that is a display, more user-friendly display name. And that's my full enum. Transit has a constructor, so reminder, abstract classes can have a constructor. I've got my getters and my setters. I've got a abstract method for printing the maintenance plan because I want to force all child classes to implement that method, but I know they're all going to probably do it differently, so I just implement that. I make that abstract. I don't implement that. I have my toString, which just includes all of the instance data variables. In my equals method, I've decided to compare by all of the instance data variables. That's what's going to make two transit vehicles equal or logically equivalent. I've used the approach of taking the absolute value, math.abs, of the difference between the two fares, since fare is a double, and comparing that to some small threshold. This accounts for issues of Java of precision and how Java stores floats and doubles. So that's a good way to compare doubles. For strings, I've compared them either with equals or equals ignore case. I've ignored the case on a route name, figuring, uppercase n, lowercase n, that's both the n line, right? Vehicle ID, I've decided to account for case. So the transit ID A123 capital might be different than A123 lowercase. For enums, you can use the equals method or the double equal sign. Either will work and they actually do the same thing. And then for my ints, I just use a double equal sign to compare. For my compare to method, I've decided to order my transits based on the route and then the capacity. So you could think of lots of different ways you might want to order your transit vehicles, but this is just the one that I picked. So I'm going to first by route. So if two transit vehicles have a different route, that's what they'll be sorted based on. But if they have the same route, they'll then be sorted based on their capacity. Okay, so that's that. Let's switch over to our interfaces. So this is my drivable on the road. It's just got a single method, dedicated lane. And then I also created a constant called dedicated lane equals true. So this is a nice kind of descriptive constant that classes who implement this interface will be able to use. I've got my controllable speed that just has my get min and get max speed methods. I've got my payable, which just says whether or not you accept a card, so one Boolean method, and then I also again have a constant here that might be useful for the child classes, or the implementing classes, I should say. So let's look at the bus class. My bus class extends transit, and it implements drivable on the road because buses drive on the road. I've added some additional variables to represent the wait time, and then the Boolean, whether or not they accept a card, and whether or not they have a dedicated lane. I've created two constructors. So the second constructor takes in all this information as a parameter, right? So you can see it's got lots of parameters. You can specify whether this particular bus object accepts cards or not, because we said that some do, some don't, and whether this particular bus object has a dedicated lane or not. Some do, some don't. Then I've also included an overloaded second constructor where I'm using some default values. So my default value for buses is that they do accept a card, and that accept cards constant comes from payable. Okay, and then my default for dedicated lane is not a dedicated lane. So my default value is that a bus would not have a dedicated lane. So I give two different ways for someone to create my bus object. I use super from my second constructor here to invoke that transit constructor to initialize all the parent parts of the object. And then in order to reduce duplicated code, I use my this keyword to invoke my overloaded constructor, passing along those default values. I add my getter and setter for wait time. I update my toString by adding a little bus onto the beginning of it to say, hey, this isn't just any old vehicle, it's a bus. And then I include the toString version of from transit, and then I add on the average wait time. For my accepts card, that's just going to return that value, same with dedicated lane, and I just have some placeholder printouts for maintenance plan. Okay. For high-speed rail, I declare my constants. I declare some constants for min and max speed because my class here extends transit and it implements controllable speed because you can control, in theory, the speed of a high-speed rail. But I said in my description that all high-speed rail trains have the same min and max. There's no variation among the objects. So if everything in my class has the same characteristic, I don't want to make it a variable because it doesn't vary. It's the same for all objects. So I just made it a constant. And when someone creates a high-speed rail object, I don't ask them to send in the min and the max speed. I'm just going to use, in my getter and setter, those constants because it's the same for all objects. Now, I also said that all high-speed rails accept a card. So again, when I override that accepts card method, from that interface, I'm just going to return that default value of true. There's no way for someone to change this either through the constructor or through a setter and that's good because I said as part of my problem description that all high-speed rails should accept a card. So I want that to be a fixed value that doesn't vary within objects of that class. Now light rail on the other hand, actually, let's switch to Subway first. Subway, on the other hand, again, Subway extends transit, also implements controllable speed. But I said that Subway cars might vary. Different Subway cars might have different mins and maxes. So I do provide a constructor that allows someone to create a Subway object by specifying the min and the max speed. And so then I invoke the super constructor, the transit constructor, and then initialize min and max speed. I also allow someone to say, well, I'm just going to use those defaults of between 0 and 50, so they don't have to specify the min or the max, or they could just specify the max. You could also have them just specify the min. And maybe that would make more sense since this is a common max for everybody. You can think about what might be better there. We also probably should include some error checking here to make sure that max speed isn't greater than 50. Because we did say that was a ceiling. You can think about how you might add that. Here we just use that constant for accept cards because we've said that all subways accept cards. So that's just going to be the constant value. We return the min and max speed, print out the maintenance, override toString, again invoking that parent version. For the power source, I kind of skipped that. I forgot that I skipped that. For buses, we've said that there's options, right? Buses might be, they might run on different things. So we take that power source in as a parameter to the constructor. For high-speed rail, we do as well, right? Because I said high-speed rail. Where's the power source? Did I say? Well, maybe I didn't specify. I think I didn't put that on my description here. But I was thinking, sorry, that high-speed rails might differ also in their power source. For subways, I've said that subways don't differ in their power source. We're going to say that all of our subways are powered by electricity. And if that's the case, I just remove that from a parameter. So if I am saying that all subway cars, all different objects of this class are going to share the same power source, I don't want that to come in as a parameter. I just want to specify it as a constant, have it be defined as part of the class. And again, I apologize, I left that out of the description of the classes. So the last one we have is light rail. And here we're going to implement drivable on the road. I also defined here that for light rail, the power source is always going to be electricity. That's not going to vary. And here I have my variables for accepting a card, having a dedicated lane, and allowing bikes. So I added an additional variable here, allowing bikes. I have my constructor that takes in all of that information. And then I have my constructor that allows you to use some defaults. The default of accepting a card being true, dedicated lane being true, so I allow you to leave those out of the constructor. I have my getter and setter for allowing bikes, my accepting card and dedicated lane, maintenance plan, and toString. And to the toString, I've also added on that information about the bikes. So that's the kind of overview of my classes and interfaces. Here's my little tester program. So all I've done is I've just created some objects and added them to a list. I created some variables here just to make it a little bit more readable of what we're looking at. You can see that I've invoked all the different constructors, so I encourage you to kind of look through that, look at what all these different choices are, and think about what the default values are that are being used. But we're just going to quickly run through using this. So again, I've created a list that holds type transit, holds the parent object. So if I wanted to create a loop, I'm just going to create one loop to do all of this. So if I wanted to say for all of my transit vehicles in my transit list, okay, what if I wanted to print out all of that, print out the vehicle? Well, I could say just system.out.println vehicle. Now, behind the scenes, I know that that's invoking toString, right? I don't have to write toString, but I know that's what's happening. And I'm allowed to do that because toString is defined an object. So all classes inherit a toString method. So it's going to exist in that parent class. So I know I can invoke it. And at runtime, the proper version is going to be called. So when I print this, when I run this, you're going to see that the, for example, the bus version prints out the wait time. The light rail prints out whether or not bikes are allowed. And some of these other differences that we've put into the overridden toStrings, the proper version will be called because of polymorphism. So at runtime, the proper version is called. So actually, I do want to create a new loop because I wanted to sort that. So I then want to sort my list. And I can do that because my transit class implements comparable. So I am allowed to sort it. So you can see now it's just the list is in the order that I added the objects to the list. But if I sort and print again, you will see that they are then added, or sorted rather, by route name and then by, did I miss here? You'll see that they are sorted by bracket problems. Route name, and then, and actually I'm going to put a break in there, by route name and then by capacity, because that's how I define my compare to. So you can see the second list here is grouped by route, and for those that have the same route, they are ordered by capacity. Okay, so you can take a look at that sorting. To print the maintenance plan, we can just invoke print maintenance plan. And I can do that because that method is declared, if I spell it correctly, in the transit class, the parent class. So even though it's abstract in that class, it's still there. The compiler just still sees that it's there. So I am allowed to I'm allowed to invoke it. Of course, I have to know how to spell it. And then at runtime, the proper implemented version will be invoked. Okay, there we go. Okay, so what is the average wait time of all the buses? Well, what we can do is we can sum it all up. So we can go through all of our vehicles. And we need to only know now, we only want to look at the buses. So we need to use polymorphism to figure out which of these vehicles is a bus. So what we can say is we can say, okay, well, if that vehicle, instance of bus, then I know this one I'm looking at is a bus. I know that. I still need to tell the compiler that. So I can say, I'll just use a temporary cast instead of a local variable. I'll say my total wait time plus equals cast to a bus. Get average wait time. And that's going to be my total. And then I will also I'll count them up. And then at the end, I'll print them all out. And first, I'll calculate it in a separate statement. The total wait time divided by the count. Now, any problems here with calculating this average? Total wait time and count are both integers, so this is going to give me integer division. If I want the full mathematical answer, I need to either cast one of these to a double or multiply one by 1.0. One of them by 1.0 to convert it to a double. But that's going to allow me to calculate the wait time. Okay. Show all vehicles that could be intersecting with traffic, meaning they do not have a dedicated lane. So for this, I'm going to cycle through and I'm going to say, well, if the vehicle I'm looking at is an instance of, and I can do instance of with an interface. I'm going to say it's an instance of drivable on the road. Then I can say, well, okay, let's cast it to type drivable on the road. And once I cast it, I'm allowed to invoke a method on it, and I can say if it has a dedicated lane. And then I'm just going to print it. Okay, so again, I have to have that instance of to prevent runtime crashes. I have to have the cast to actually let the compiler treat it that way. So I do need both. Oh, and actually I want the negative, so I want the ones that do not have a dedicated lane. So let me put a not on that. And we'll take a look, and that's going to give us these two bus and light rails. Okay, they're both mixes with traffic. I think I didn't add that onto my bus toString. I could consider doing that. Okay, let's get the all vehicles that accept a card. So for this one, do I need to do any sort of instance of and casting? Well, I know that that accepts card is part of the payable interface, which is implemented in Transit. So I know all of my child classes are going to have that method. So I don't need to. So I can say just say if vehicle accepts cards, I'll print it. And again, I don't need to do any casting because that accepts cards method is declared in Transit because Transit implements payable. And so all of the child classes are going to have that method implemented. You can see these are all the ones that accepts cards. And that proper version will be invoked at runtime. Similarly, for the fare, I do not need a cast because all of my transit vehicles have a fare. Remember that fare is declared in the parent class. So I can just say if vehicle.getFare is less than 5, print it out. And again, I'm allowed to do that because getFare is declared in the parent class. To show all the electric vehicles, I can get the power source, and again, I'm not going to need to do any casting here because that power source is declared in the parent class. So I can just say, well, if my vehicle dot get my power source dot equals power source dot electricity, print it out. And then finally, I will show all the Route 43s. And again, for the route, I do not need to do any casting because again, that is declared in the parent class. So I'll say if my vehicle dot get the route name dot equals ignore case, or I can think about doing contains if I want to just know if it contains it at all. Again, I'll print it out. So you can see here, you can think about how you might be able to access a system like this to kind of do different queries and get different information out of your classes, right? So it's important to think about how you can structure them so they logically make sense and also support this ability of, asking questions if you had a data set that used these classes. So important things to think about is when you want to extract information or a functionality that applies to all your objects, and you don't need a cast. If you want to narrow in on functionality of just a certain subset of your objects, at which point you need to use both the instance of and the cast together. Always use those together. So hopefully this example kind of tied everything together. We use an enum, parent and child classes, abstract classes, interface, equals compared to all of that. Hopefully that kind of tied everything together for you. If you have questions about this, or again, if you want to discuss your approach and how it was different, we can kind of talk through the pros and cons. I encourage you to do that on the discussion board.